All right, the sampling distribution model for a proportion, provided the sampled values are independent and the sample size is large enough. The sampling distribution of p hat is modeled by a normal model with mu of p hat being equal to p and the standard deviation of p hat being the square root of pq over n. So in a really large bag of M&Ms containing 500 candies, found that about 12% of them were green. If the company claims that 10% of the M&Ms produced are green, is an unusually large proportion, or is this an unusually large portion of green M&Ms? So our mean, according to them, is that 10%, so it's 0.10, is how many are produced. Standard deviation is the square root of 0.10 times 0.90 over 500. Do you want to give that one a guess, or can I just tell you what it is?
So, 0.1 times 0.9 is 0.01 is the top. And divided by 500. Don't say nothing. Yeah, it's some absurdly small decimal.
Yeah, it is. It is 0.00018. So the square root of that is 0.013. So I'm going to make a curve. So we have our mean of 0.10. Then I'm going to go, or count out the standard deviations away. So then this would be 0.113. This is 0.1. I think it should be 0.113 plus 0.013. 0.126 plus 0.013. 0.139. Then subtracting 0.087. 0.074. 0.061. So 2 standard deviations away is what we consider unusual. So anything more than this away, we would say is unusual. So is the 12% unusually large proportion of green M&Ms? No. Because this is only 12.6%, so 12% is inside of that. So it is not unusually large. %12 is less than 2 standard deviations from the mean, so not unusual. Public health statistics indicate that 26.4% of American adults smoke cigarettes. Using the 68, 95, 99.7 rule, draw and label the distribution of the proportion of smokers among a randomly selected group of 50 adults. And then, do you think the appropriate conditions necessary for your analysis are met? So, my mean would be what?
Mean would be 26.4.
Yeah, or 0.264 is a decimal. So then standard deviation would be the square root of 0.264 times 1 minus 0.264 is 0.736 over n would be 50. And this comes out to be 0.062. So it wants us to set up the distribution following this rule first. So we're basically just drawing this diagram again. So my mean is 0.264. So then we have 0.326, 0.388, and 0.450. Then subtract 0.202, 0.140, and 0.078. So then we just label the 68, 95, 99.7, so 68, 95, oops, and 99.7. So then what conditions am I checking for part B?
Randomization.
So is it random?
Yes.
Okay, so random. Check. What else?
10%.
So is 50 adults less than 10% of all American adults?
How can you determine?
Well, so are 50 adults less than 10% of all American adults? So, yeah. So 50 adults. It's pretty safe to assume if you're given the problem, it's going to meet the conditions, but it's not 100% guarantee. And what's the other thing that we check?
Success.
So,
Success or failure.
yep, so success, failure. So we need NP, which is 0.264 times 50. And that's 13.2, which is greater than or equal to 10. So that one is good. Failure NQ is the 0.736 times 50. 36.8 is greater than or equal to 10. So that one's good. So being that all conditions are met, or the appropriate conditions are met, so a normal model is appropriate. Alright, so assume that 30% of students at a university wear contact lenses. We randomly pick 100 students. What are the mean and standard deviation for the proportion of students in this group who may wear contacts? So start with the easy stuff. What's the mean?
The mean is 30%, 4.30.
Yep. And then standard deviation, how would we find that?
The square root of 0.3 times 0.7 over 100. And that would be 0.2 over 100. So that would be the square root of 0.0021. And that is Mark Stokes.
Yep. So that would be 0.046. Approximately. So let P hat represent the proportion of students in this sample who wear contacts. What's the appropriate model for the distribution of P hat? So what do we need to assume first?
N is large enough.
Okay, so assume the conditions are met first. What kind of model would we use then?
Normal.
Yep. Normal model. And so we would do that for n of 0.3 and 0.046. That's just the mean and standard deviation. So what assumptions underlie your model and are they met? So we care about random selection, which we know occurred because it says we randomly pick 100. 10% condition. Are 100 students less than 10% of all university students?
Yes.
Yeah, so yes, because 100 students are less than 10% of all university students. And I would say, I mean, obviously, you could just be talking about for that individual university, or you could be talking about all universities across the country. But I would still say overall, you probably have more than 1,000 students in a university, no matter how small they are. So you can still make that assumption. Success, failure. So NP is 0.3 times 100, which would be 30. And that's who we expect to wear contacts. And that's greater than or equal to 10. Then NQ would be 0.7 times 100, which is equal to 70, which is who we expect to not wear contacts, which is also greater than or equal to 10. And the sample is not too big and not too small. So it's large enough and it's not like over the top. So what's the probability that more than 1/3 of this sample wear contacts? That implies that y bar is equal to 0.33. So then we're going to use the z-score. So z is equal to 0.33 minus 0.3, so actual minus predicted, divided by the standard deviation, to 0.046. Interesting. .652. So then we're going to use normal CDF to solve this. So normal CDF of, we use this number, 0.652, 1E99, 0 and 1. So 0.652. And that comes out to be 0.257. So then based on the normal model, the probability that more than 1/3 of the students in this sample wear contacts is about 23.4%. Or I mean, wow. Hello, that's the number that's on my paper that's wrong. 25.7%. All right. A national study found that 44% of college students engage in binge drinking, which is 5 drinks at a sitting for men, 4 for women. Use the 68, 95, 99.7 rule to describe the sampling distribution model for the proportion of students in a randomly selected group of 200 college students who engage in binge drinking. So, key here, it does say randomly selected. So, the mean would be what? Or just like what's the mean for this in general?
0.44.
Yep, 0.44. Standard deviation.
0.44. The square root of 0.44 times 0.56 over.
And check and make sure this is right. This is 0.035. So my mean is 0.44. So then plus 0.035. 0.475. 0.51. 0.545. Then the other way. 0.405. 0.37. 0.335. So then we just have to draw in the 68, 95, blah, 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 blah. So 68, 95, 99.7. So basically from that, we would say that if you were going to actually really write it out, but I'm not because it's already pictured, that 68% of the sample size of 200 are expected to have 40.5% to 47.5% of binge drinkers. 95% of the samples are going to have 37 to 51% and so on and so forth that are binge drinkers. So that's all that means. So do you think the appropriate conditions have been met? So is it random? Yes, it's random. Success, failure. I know I'm doing these out of order, but NP, NQ. So 200 times 0.44 is 88. And 200 times 0.56. All right, you got it.
Wait.
Well,
Half of 200 is 100. So that's
also, how many people are left?
112. I didn't want to look at the 200. I want to solve it.
You did solve it, just a different way.
Yeah.
Work smarter, not harder. All right, how about 10% condition?
Is it students of like the college or like all colleges?
This is a national study found that 44% of college students, so I would say of all college students.
So no.
200 is not less than 10% of all college students in the country.
Oh wait, yeah. I meant you know what I meant.
Well, that's what I thought, and I was like, wait, why did he just say that?
I meant no. I don't even know what I was thinking. I think I meant like, no, 200 students is over 10%. Or not, well, I'm gonna stop talking.
So all conditions are met, meaning we can use what? So we can use normal model for 0.44 and 0.035. So after hearing of the national result that 44% of the students engage in binge drinking, a professor surveyed a random sample of 244 students at his college and found that 96 of them admitted to binge drinking in the past week. Should he be surprised at this result? So we already know the mean, but our standard deviation is going to be different because the number of students that we're sampling is different. Freshman?
Jake.
Oh. So yes. Alright. So we already said basically the conditions were met, but again, since we did change, the conditions are still met, so we're good. So he sampled out of his 244, 96 of them were binge drinking in the last week. So our Y bar, which is our actual, okay, is 96 divided by 244, which would be what? Or do you know that off the top of your head?
I'm gonna take a guess. So what's half of 244? 122. So 1/4 of that is 60. So it's between 25 and 50. I'ma say it's about I'm gonna guess and say 38%.
Almost. 39.
I was gonna say that. I was really gonna say that.
So that's 0.39. Okay, so basically, just to give a quick little sketch of what we're looking at here, our mean is still 0.44. I just found it's 0.39 for this one. So I need to find my new standard deviation with the new information that I was given. So my mean stays 0.44. Standard deviation is now the square root of 0.44 times 0.56 divided by 244. So that's what changed. So 0.44 times 0.56 divided by 244. Whoops, nope, not that. 0.2464 divided by 244. And second square root of that is 0.032. So I find the z-score first. So z is equal to 0.39. So actual minus the predicted was 0.44. Divided by the standard deviation of 0.032. It's going to be negative 1.56. Then, oh. So this right here tells you how many standard deviations away it is. So I actually don't have to do anything else. So this says that 39% is about 1.6 standard deviations below the mean, which is not terribly unusual. So I don't even have to do anything else with that. Yeah, last page. So we'll probably finish it. Oops, not that. Edit.
No power over this time.
Huh?
No power over this time.
Well, I mean, basically, but we should have, we have about 10 minutes. We should be able to finish it. All right. A restaurant owner anticipates serving about 180 people on a Friday evening and believes that about 20% of the patrons will order the chef's steak special. How many of those meals should he plan on serving in order to be pretty sure of having enough steaks on hand to meet customer demand? Justify your answer, including an explanation of what pretty sure means to you. Ow. So sore. Okay, so we're gonna look at the conditions. Is it random?
Yes.
Check. 10% condition.
Serving about 100 people on a Friday evening. Is it 10% of what population?
So it would be 10% of all potential people that could come to the restaurant.
Like throughout the course of like history.
Like for the day.
For the day.
So think about like, I'm just going to use Chick-fil-A for example. So they're preparing, which not they would prepare steak, but hypothetically they were going to prepare, we'll just say chicken, for whatever. They're looking at 180 people as how many they think are going to come in. But how many people in this city alone could theoretically come to Chick-fil-A tonight if they really wanted to?
We were just going to say hi, but you're teaching. So, bye.
Hi, bye.
I mean, I think it could be over 10%.
If you're looking at a small town, maybe.
Small town.
I said if you were looking at a small town.
I guess probably not.
But I mean, like Newport News has what?
I think like 150,000.
So 180 would be significantly less than 10% of that, right? Yeah. So 180 is less than 10% of all potential customers. And success failure, NP would be 0.2 times 180, which would be 36, and NQ would be 144, which is greater than or equal to 10, so we're good there. So I can use a normal model for 0.2, and then I need to find the standard deviation. So what would how would I find the standard deviation?
So it'd be 0.44 times 0.56.
Where'd you get 0.44
Oh,
from?
was it that's I think the last problem. 0.2 times 0.8 over 180. And that would be maybe 0.16 over 180. Since we're short on time, I'm not gonna solve it right now.
All right, it ends up being 0.03 because it's a 9, so it rounds up 2 things. So then I'm going to look at a drawing here, and then I'm going to get some information from that. So the mean was 0.2. So adding 0.03, I'd have 0.23, 0.26, 0.29. So anything unusual would be more than 2 standard deviations away. So I'm going to say 0.26 times 180. And that's going to be basically 47 steaks. Okay, round it up. So, how many of those meals should he plan on serving in order to be pretty sure of having enough steaks on hand? So, basically, he needs 47 steaks because that's 2 standard deviations above the mean. So, it would be unusual to need more than that. And so with 47 steaks, I would be pretty sure that there is enough to meet the demand. All right, this next question has a 10. That was almost really cool. All right, this question, this is supposed to say 30%, not 305. So, in a special promotion bag of candy, Groovy M&Ms, and last year they asked me what that is. I don't know what Groovy M&Ms are supposed to make up 30% of the candies in the bag. In a large bag of 250 M&Ms, what is the probability that we get at least 25% Groovy candies? Again, what does that mean? I have no idea. So, is it random?
Yes.
Yep.
Is
Tim?
all of them random?
Pretty much. Really, unless it says otherwise, we're assuming it's random. Pretty much all these conditions should always be met. All right, 10% condition. Are 250 M&Ms less than 10% of all M&Ms ever?
Yeah.
Check. And success failure. NP. So 30% of 250 is 75. NQ, 30% or 70% of 250 is 175, which are both greater than or equal to 10. So again, that condition's met. So I can use a normal model. Oh, I didn't ever put this in here. So for 0.3, and then we'll find the other number. Standard deviation is going to be the square root of 0.3 times 0.7 over 250. That comes out to be 0.029. So then z-score, actual, what we got was 25% minus the predicted is 30%, so 0.3 divided by 0.029 is minus 1.72. And it wants the probability that we get at least 25% Groovy candy. So the last question, we were just wanting to know how many it was that were 2 standard deviations away, basically. So in this one, we're going to need normal CDF of minus 1.72, 1 E99, 0 and 1. So minus 1.72. That ends up being 0.957. So then, to conclude that, according to the model, or according to the normal model, the probability the bag has at least 25% Groovy M&Ms is about 95.7%. And just in case you wanted to see what this looked like, because I know we kind of went through that fast, basically Our mean was here. We wanted to know about anything bigger than 0.25, so that's why we did the normal CDF the way we did, of it being over that. So tomorrow